Another vector tutorial. In this stage we are solving question number 9. It's Cambridge Advanced book and exercise number 13.4. I wrote here. It's written here at 15 hours a submarine departs from a point A. It's the starting point, travels a distance 120 km to a point B. That's the information written there. From A to B it travels a distance 120 km. Position vector of R of the submarine relative to O t hours after 15 is given by that information. So first question, write down the position vector of the point A. We can write this position vector like this. First one is a 15 by 20. Then second one, if we take t common, we can write as a 8 and 6. So we can diagnose this here. Actually first part of the vector, it is A plus TV. If we compare with this, so that one is called the initial position and this is the final one is called the velocity vector. So if we write down the position vector of the from point A, we can write as a OA, which is A. This is actually 15 20 can write. This is our answer. We also can write 15I plus 20Z, same thing. First one is a column vector form and second one is a vector form in terms of ing. Second one, the rotate the velocity vector of the submarine. Easily can write, we already isolated the velocity vector 8 and 6, so velocity vector we can write 8I plus 6Z, and this is our answer of the B part of question number 9. Now we are in question number C. Find the position vector of the point B. That the information is given. Position vector of point B. This is the question. So we have to find out first t value, because it is written here from A to B. Say if we draw a diagram from A to B, let's see, this is the point A to B and it travels a distance of 120 km is given, 120 km. So it's actually from A to B, it travels under this velocity 8a plus 7j. So first find out the speed of this vector 8 square plus 6 square, and we would get from there 10. So we can write here speed into time, so 10 into t equals to travels a distance 120 km. From there we got the value 12 hours. So now let me find out the position vector of the B. This is the position vector of the B. We can write OB equals to that one, because it is written here from the original position. At the time t equals to 12 hour, it is at the point of B. So for C can write position vector of B. Just put this value of t in the main equation, which is 15 plus 8 into 12. Then next one is 20 plus 6 into 12. So the value comes out from there. Let me calculate. The first one is, it is 15 plus 8 into 12, 15 plus 8 into 12, and it gives us 111. The top one is 111 and bottom one 20 plus 6 into 20 plus 6 into 12, and it is 92. So we can write 92 on the bottom, and the final one is 111i plus 92z, 111i plus 92z. This is the final answer of this question. Hope guys, the way we did the question you understood. Similar working for question number 10 and 11 as well, and you are welcome to solve that question also in my next tutorial. Thanks for watching with patience my tutorial.